promise I'll give you your class soon.
Oh, no worries.
But the I've got the date for most of the lab trips. There's one that I'm waiting to hear back from Dr. Dalton on, but it looks like it's pretty much going to be every other week. It's September 21st. We'll be doing a couple of trips here locally to produce auction, and then Randolph Henry High School has got a land lab. October 5th, we go to State Fair. October 19th, Mayor's Pumpkin Patch. November 2nd, we're going to Morris Cattle Farm in Nottoway. So those of y'all here in the Keysville, South Boston side will be riding for a while. November 16th is pesticide training. I'm not sure if we're going to do it, which location we'll do that at. The one that's up in the air is whether it's going to be November 30th going to the bull sale or December 7th going to a poultry operation. We'll probably do the bull sale on the 30th, but I just found that date after Dixie emailed me saying that she wasn't sure when it was, so we got to verify it with her. But September 21st, October 5th, October 19th, November 2nd, November 16th, those are definite. I'll have an email or I'll post announcements in Blackboard here in a little while, but this is fresh off the press and sitting on my mailbox this morning. So, does anybody have any other questions for me before I turn it over to him? We having Alberta, did y'all connect? Y'all aren't there yet. Let me retry the dial then. They're not answering. It looks like they're connected. I don't know. I bet your TV is off. Okay. I guess y'all talk amongst yourself. I got a call. Get somebody to see what's going on.
Looks like everybody got the quiz in. Did anybody have any trouble with the quiz?
Hey, Anthony, it's Tom Scales here. Can somebody go up to B35? They're supposed to be connecting to Zoom. It's got the green button, but nothing's happening. I don't know if the computer's not on or. Oh, I'm in 71. Yeah. But I think what happens where we reinstall it, it's on that computer, it's not set to automatically answer. Because I just got a message that it declined me. Yeah. Okay, I'll dial back in about 60 seconds, give you a minute to get there. Okay, all right, bye. Okay, the computer in Alberta died the other day and they put a temporary one in and it's not set to automatically accept the calls. And apparently the students aren't actually doing it. So I've got somebody running up the hallway to.
No worries.
Second. Yep. The sad thing is this is a temporary computer. They're gonna so we can't really do anything to set up in it because they're gonna take it out in another week or two when they get the actual real replacement. They stole this one out of a computer lab somewhere. But,
always having problems with technology.
Yep. Yeah, and then the printer here in Keysville isn't working, so. Okay. Hello, thank you, Anthony.
All right, I'm gonna try to fix the auto answer real quick.
Okay.
Let's see.
If you're in the settings, you can do the remote camera control too, so I can zoom it around to see people.
Okay.
If you go into Zoom settings, if not, don't worry about it.
I add auto answer. Okay, so you good for next time.
All right.
All right, and then say.
Okay, Ben, I guess you can go ahead and teach while he's not doing anything that should impact us.
All right. Well, Sounds good. I got most of the quizzes, well, all the quizzes that were turned in graded, so most of them were pretty good. There were a few that were a little lacking, but just wanted to go over a few things that were often missed. One of them was the whole issue with shattering, and so many people missed that I gave you credit anyway. But anybody tell me what shattering is?
It's like when the seeds fall off of like things like wheat, right?
Yeah, exactly. So shattering is the process of the seeds maturing and then basically just falling off. The mutation in shattering that helped to cause the beginning of agriculture was that they remained on the plant so that they could be harvested. So that was something a lot of people miss, but gave credit anyway. Just want to make sure you guys got that, understood that. Also, on the seemed to be some confusion on the genetic engineering versus genetic modification. GMO, or genetic modified organism, is the kind of the popular term, but really it's the less scientific term. Because technically we can look at any of those traditionally bred plants as being genetically modified. Genetic engineering is the more scientific term to use. So quite a few people missed that. Just wanted to make sure that everybody was on the same page there. On the kind of short answer / essay question, what are the biggest challenges for agriculture? A lot of people put overpopulation. Absolutely true. A lot of people also put urbanization, which is also true as well. And I think urbanization in the United States, in terms of farmland, is slowed down a little bit. Of course, it just depends on the area too, and that's partially to do with the housing market. And whenever the housing market starts to decline, there's less urbanization development taking place in rural areas. So kind of have to watch that. But yes, definitely an issue. So just wanted to touch on a few of those things. I'm going to put up the quiz for Chapter 2 today. And we'll basically give you guys a week to complete that. We're a little bit behind, and that's mostly my fault. So for that, we're going to try to catch up this week and try to cover both Chapters 3 and 4. So hopefully by the end of next Wednesday, we'll have both chapter quizzes up and running, and we'll give you a whole week to take those. That should catch us back up. I'm not going to be here next Monday, week from today, so just want to let you all know that ahead of time. What I'll do is basically record my voice over the PowerPoint lecture and post that for you all. So I'm not sure exactly how you want to work that out. If you guys just want to come in a little later for your next class or whatever, but I'll get in touch with Tom about that here a little bit later today. All right, well, let's talk about Chapter 3 a little bit. And Chapter 3 is all about growing plants for human use. So we're still really kind of in the very general aspects of this first unit of kind of what does it all mean? What is agriculture? What does it all mean for us? So let me see if I can share my screen with you guys. I already put this up, this PowerPoint that I've edited. So again, I would recommend kind of looking at the original PowerPoint and the edits that I've made, just so that you can see where I've added. Try to highlight anything that I think is of significance or where I've edited. So let's see, here we go. All right, you guys seeing that?
Yes.
All right, so talking about plants and nutrition, of course, we talked about this in the ecology aspect, but the trophic levels, they're referring to the ecosystem, how it moves up the food chain or food web. So plants, of course, are autotrophs versus animals, everything else being heterotrophs. Plants are the only autotrophs because they're the only things that can make their own food. Fungi are kind of interesting because they're semi-autotrophic. They are decomposing organic matter, but they're not actually making their own food via photosynthesis. Therefore, they are also considered heterotrophs. Just a question I wanted to point in there. Are we at the top of the food chain? What do you guys think? Are humans the top of the food chain? Or the pinnacle of the food web? I don't know. It just kind of depends on how you look at it. That's something to think about. In a natural ecosystem, maybe, maybe not. Depends. If we are the actual prime predator, but there are definitely some cases and some times where we are not. I don't think we generally, I mean, I guess we might hunt and eat grizzly bears in some cases, and maybe the Inuits, they did hunt polar bears, but in some cases they were also hunted as well. Think about that. We're actually eating very few plant families as compared to our ancestors. When we were hunters and gatherers, we actually had a more diverse diet than we have today. So basically, this is just outlining the crops. Cereal crops, of course, are grains and basically represent half of the world's food supply. Then, of course, we eat lots of roots and tubers. And generally, in terms of energy, a plant's natural energy goes mostly into cereal crops, the seeds, things that come from seeds. Energy from seeds are where most of the energy that plants develop photosynthetically, or also roots and tubers. So if we think about it naturally, that's where plants store most of the carbohydrates and proteins. Of course, we use them in different ways, like oil crops, sugar crops. Fruit crops often contain seeds as well. Vegetable crops are a little bit different. Interesting thing here that I wanted to talk about the way that we kind of represent fruits and vegetables. Botanically speaking, a fruit is any crop that contains seeds. But a vegetable is not, does not contain seeds. It results from basic vegetative growth. So on this list here, they put tomatoes, melons. Technically, those are not, botanically speaking, not vegetables. Of course, all these fruit crops are fruits, but botanically, vegetables are only from vegetative growth. There is a little bit of, I guess, legal jargon associated with that. I guess technically, tomatoes by the Supreme Court are actually considered a vegetable. And that's part of kind of fitting into a balanced diet. You can count it as a vegetable, even though technically it's a fruit. So lots of blurred lines there with the legal world versus the botanical world. But nonetheless, we actually have less of a diverse diet than we did, thousands of years ago.
Were you joking when you said Supreme Court about the tomatoes?
It's true.
Oh my.
Technically,
anything better to do than decide that the tomato is a vegetable, not a fruit.
Yeah, exactly. I think it's kind of ridiculous, really. But yes, tomatoes are defined by the court system as a vegetable. And again, I think that's kind of related to how that fits into diets for like school children.
Yeah.
You can count, if you have ketchup in there, it counts as a tomato and therefore as a vegetable.
Yes. Anyway. Moving on. Oh, I'm over here crying.
The chart on this slide shows caloric and protein content of crops, of our most important food crops. So that's kind of interesting to look at. Calorie-wise, sugarcane is number one. because of the massive amounts of calories that we get from sugar. Soybeans are the number one for protein. But something that I would point out is that we generally do not eat soybeans or sugarcane in its raw form. These are processed crops, and in some case, extremely processed. It's really actually not very good to eat soybeans that are not processed. Of course, edamame is a little bit different. That's the raw version of a steamed soybean pod. That's a different variety of soybeans. Most of the soybeans that are grown in the Midwest are, almost inedible in their raw form. So anyway, that's interesting to look at this this chart, this table 3.1, and some of the things that they wrote here with it. That, of course, not all of the total production for food materials is available for human consumption. We don't eat the leaves, right, of soybeans or sugarcane or potatoes. We're only eating part of the crop, and because of that, we're losing some of the energy that is embedded into the crop during the harvesting, the transportation, and the marketing of the crops itself, as well as some of the nutritional content. As soon as you harvest something, for most things anyway, and there are some instances where vitamin content can improve, but for most part, once it's harvested, it's slowly beginning to degrade nutritionally. Of course, our modern diets, let me go back here. Our modern diets, they say that we need 2,000 to 3,000 calories, and the kcal there just means kilocalories, which is pretty much the same. It's a form of a measurement of energy, right? So 2,000 to 3,000 calories is the modern American diet, they say. But how many of us actually, in some cases we probably eat less, some cases we probably eat much more. So where does that energy come from? Often from carbohydrates and lipids, mostly. Those are the most energetic forms of basically nutrition from plants. So as they write here, 24 to 36 slices of bread is one way to get our daily energy requirement. Anybody eat that much bread in a day? That's probably not good for you. So they have 700 calories there in like half of a loaf. Or in the lipid form, the fat form, we've got oil here, and you can basically have like 1.5, 2 cups of oil is the same energy content. So, however, that's not all of our nutrition. If we're just talking about calories, we're missing the big picture. That's just energy, right? Easily burnable energy. Although sometimes, I don't know about you all, but if you're at the gym and you're working out a little bit, you ever on the treadmill and you see like the calories burned come up? And that's kind of depressing, isn't it? It's like you're on there for like half an hour and it's like, oh, I burned like 300 calories. Great. That'll take care of a few slices of bread, right? Anyway, energy and nutrition kind of go together. Of course, it depends on the person, right? We have this kind of 2,000 calorie daily requirement, and that's what all the nutrition facts are based on in the U.S. But realistically, if you have a high burning metabolism and you're extremely active, then you're going to be burning a lot more than that. Back in the day when I was hiking the Appalachian Trail, we would try to eat about 5,000 calories a day. And of course, we would burn far more than that every single day. I would try to eat 1,000 calories for breakfast. That was my goal, which is kind of difficult. I'd eat like honey buns and stuff like that. If you're talking about protein, a human adult needs about 70 grams of protein in a day. That's just to maintain and to continue to build some muscle mass. Of course, when you're growing, you need more than that. So that's something to think about. Most of our protein in the plant world comes from pulses or legumes. Pulses are basically the same thing as legumes, but generally they refer to pulses as those that are produced on a commercial scale. So things like peas, beans, etc., soy. They do have a fair amount of protein in them. The other issue with proteins is we have to think about amino acids, which basically the way the human body works is we consume foods, and usually, probably a lot of us, like meat, for instance. We eat a large amount of protein-rich meat, and what happens? We break that protein down into amino acids with which we rebuild proteins. So we use amino acids to build proteins, and that's kind of how that happens and how we do it. In general, plant proteins often have kind of low proportions of the essential amino acids, especially in a simple diet. You really need a diverse plant diet in order to be able to get all of the amino acids that you need. Especially if we're talking about methionine and lysine. These two plant proteins are generally not in the correct proportions. And these tend to be the most limiting. So it tends to be that in most agricultural civilizations around the world, we've come up with a combination of plant proteins that makes the full amino acid suite. So generally what we're looking at is a grain and legume combination, because grains are usually lower in methionine and legumes usually lower in lysine. So combined, you get the full amino acid suite and are able to build full proteins. You guys think of any examples of a grain and legume combination found somewhere? How about like Central America or North America? Anybody? Well, we could look at them in other countries, like for instance in India, they usually lentils and rice, kind of their big combination. In Asia, soy and rice. Here in North America and also in Central America, it was usually corn and beans. So think about like a meal at a Mexican restaurant. You generally have corn tortillas and refried beans on a plate, right? Almost all of their dishes have that combination in them. And if you look at all agricultural civilizations, they tend to be those crops that were found near that area. And then their food cultures, their cuisines are kind of based around that grain and legume mixture. It's pretty cool. Of course, we also need to talk about vitamins as well, right? So I think of vitamins kind of as trace minerals. And if we're thinking about plants, of course, we'll get into this here pretty soon, but plants have a need of basically 16 essential elements. And we have 3 main nutrients, nitrogen, phosphorus, and potassium, that plants need. And then we have all these other trace minerals. So if we think about that, I think of the vitamins as sort of our trace minerals that we need. Of course, most of those are obtained from fruits, vegetables, or grains. So another reason why we have to have a diverse diet to get the vitamins. And something that I've been kind of doing some research in human nutrition, and while this hasn't been completely proven yet, there are those that believe that if we eat a diverse enough amount of fresh fruits and vegetables to get diverse amounts of amino acids from them, initially we can build proteins and actually have greater accessibility to the vitamins rather than eating complete proteins that we break down and then into amino acids and then build the proteins back. So I'm not saying don't eat meat. I'm just saying that we need a diverse diet. You need fruits and vegetables in your diet as well. So just a few of the vitamins here that they talk about. Of course, there are many more, but these tend to be some of the ones that dominate nutritional studies. Vitamin C, of course, of ascorbic acid. Vitamin A, often derived from carotene, found in colored fruits and vegetables. And then vitamin B12. And if you've seen or known vegetarians in the past, you know that that's something that they struggle with, is getting enough B12. And that's mostly because it's not really found in the plant world. It's manufactured by the bacteria that are found in ruminant organisms. Therefore, it is only available in meat and dairy foods. Of course, they do have it as supplements now. There are a few plant sources of vitamin B12, but it's hard to get enough of them in a vegetarian diet. Also, the 6 major inorganic nutrients: calcium, phosphorus, magnesium, sodium, potassium, chloride. All can be obtained from plant foods, although often more abundant in animal foods. We don't have any vegetarians in any of the classes, do we? Be interesting to see if we do in any of the online classes or anything. It's difficult to get to everything that you need in a vegetarian diet. So you'll hear some people say that we need to evolve to eat more of a vegetarian diet in order to be more environmentally sound. I don't really think that that's true. I think that it would be better if we ate more fruits and vegetables, but I don't think we need to go solely to them. So here they're talking about if an adult needs 3,000 calories a day and looking at average U.S. yields, what are the combinations that you need to get this amount of food from the land? So that's kind of what this chart is talking about, and how their figures are actually slightly optimistic. And something I highlighted here, that it is questionable whether the inputs used to attain U.S. yields are physically available and environmentally desirable on a worldwide scale. And so basically what we're talking about here is that we're using a lot of extra energy in terms of fossil fuels input into, whether it's in a tractor or into synthetic fertilizers or chemical inputs. Those all have a lot of energy embedded in them. So it's questionable whether we could scale that up to a worldwide scale. And also what the environmental consequences might be if we did. As a consequence of agriculture, again, if you look at the Gulf of Mexico, there's a huge area where there's basically no life, and that's mostly coming from sediment and nitrogen runoff, as well as some pesticides too, from the Midwest, which again is, in terms of grain crops, the most productive spot on the planet. So big question there about agriculture. If we just look at the amount of cropland per person, it boils down to about a little bit more than half an acre per person. So that is actually enough to provide every person with a vegetarian diet. But does it really make sense to do that? That's kind of something I really want to think about and have you guys think about. So we already mentioned this before, but it's definitely worth mentioning again, is that where we produce crops is where they are the most effectively produced, most efficiently produced. And again, in California and Florida, we produce more than 60% of the U.S. grown fruits and vegetables. And today, with modern technology, we're able to move these plant products thousands of miles, which again, that's more embedded energy. So just to think about what are some of the potential issues that arise from this. And is it sustainable? I'm not going to say yes or no, but I just want you guys to be thinking about that. So some argue from an ecological perspective that we should consume local produce. And I would say, yeah, I'm probably one of those people that would argue that myself. And I would say that this chart that they put here is kind of misleading. Something they need to add here is that, yes, from an ecological perspective, we should consume local produce, but we should also add in-season local produce. So if you look at this chart, they say the energy input from, they're talking about Ohio here because a lot of the authors and editors of the book are at Ohio State University. So they're looking at the energy input, transport strawberries and broccoli from Florida and California to Ohio. And then they're comparing that to lettuce produced in greenhouse production. They're saying that basically there's a lot more embedded energy in greenhouse production of lettuce. And I just want to call them out and say that that is way off. Depends on how you're talking about producing the lettuce. If you're talking about trying to grow it in the summer in a greenhouse, there's going to be a lot of energy in trying to cool it. But generally, growing lettuce in the winter in a greenhouse, you really don't have to have that much heat. Of course, lettuce is a cool season crop. So I just think that this chart is off, and wanted to kind of throw out the whole idea that, yeah, we can use greenhouse production to contribute to sustainable food production. It's not going to completely solve the problem worldwide, and yeah, this figure is going to be high because there is a lot of energy in heating a greenhouse, of course. But I think that's a little slanted there. So the nutrients in the produce are removed from the area where the crop is grown. That's another big thing I wanted to point out on this slide. We're moving food all around the country and all around the world, and therefore we're also moving nutrients. And something else that I want to think about, we're also moving water. If you think about, say, tomatoes, for instance, they're like 95% water. So when we ship them across the country, we're basically moving a packet of water. Does that really make sense? I don't think so. It depends. And it's all about people's diets. Do we need to have tomatoes in the middle of winter? I don't know about you guys, but I think those tomatoes that you find in the middle of winter, they suck anyway. I mean, they're just not, they don't have the flavor or the texture that I'm looking for in a tomato. So I think we need to alter our diets to be more in line. And I'm not saying, no, we shouldn't be eating pineapples from South America. I don't think there's necessarily anything wrong with that. I'm just saying that if we eat more of our crops locally and in place, that we would save a lot of energy there. Also, we have to think about balancing nutrient flow. The only way to really truly have sustainable crop production is to balance your nutrient flow. And right now, how we do that is by taking nutrients, nitrogen often, really from the atmosphere. Nitrogen is, in terms of our air, the largest component of our air. We can take that using technology out of the air and turn it into a fertilizer, basically. But there's a lot of energy in that, production of nitrogen fertilizer. If we can figure out ways to balance the energy and the nutrient flow on the farm, then I think we'll be better off. We'll be closer to creating sustainable production. If you try to wrap your mind around that, though, I mean, it's really difficult especially in terms of nitrogen. It is the most mobile nutrient. It's always moving. So because of that, how do you balance the flow? And we'll talk about that more later on when we get into nutrients, but just wanted to mention that now. Balancing nutrient flow is crucial. Also talking about water, and a big issue with with climate change especially is access to water. And, right now in our area, especially but you guys are getting some rainfall maybe today with the tropical storms incoming. In our area, in the mid-Atlantic, we generally have good amounts of rainfall. So it's easy to forget that there's a lot of water in the crops that we produce. For instance, as they phrase here, 1 kilogram, that's 2.2 pounds of grain, you can say it can take up to a ton of water. We're talking about 2,000 pounds of water in 2.2 kilograms, 2.2 pounds of grain. Kind of crazy to think about. However, we have a large amount of our crops being produced in arid areas. The Central Valley of California is an extremely arid area. And because of that, we're taking water and we're moving it often in open canals from rivers like the Colorado River to these dry areas because they're the best climate to produce a lot of this. So that can cause some political and environmental problems. So more kind of startling figures here. Each person in an industrialized country takes about 1 hectare, that's a little over 2 acres of cropland. So if everyone lived in an industrial economy, agriculture would already occupy all of the world's land. And that just has to do with our diets, basically. And the fact that a lot of the produce or a lot of the grain production is not actually being fed to people, it's being fed to animals. And we're losing a lot of energy in that situation. Only 10% of the energy available in food crops is actually being recovered in the meat or other animal products from basically confined animal feeding operations. So it's kind of a big issue if we think about that. The stock farm has a problem also disposing of animal waste, which actually contain the same nutrients as the fertilizer, but it's in a different place, right? So has anybody been through the Midwest and seen these large feedlots? Or maybe through the Central Valley, California? Anybody? Raise your hand if you have seen that, if you've seen a large feedlot. Well, I would recommend witnessing that at some point in your life. Go to a feedlot sometime just to see what it looks like. I guarantee you're going to smell it a lot sooner than you see it. However, on the other end, if we think about grazing animals, it's actually quite a bit more sustainable. If they're fed forage or allowed to graze pasture, then ruminant animals, we can actually recover as much as 50% of that energy through crops grown for human consumption. So, and also land that is unsuitable for crops could be grazing land for animals. As you may see in your area, and we see a lot here in Southwest Virginia, it's too steep to grow crops. It's not technically arable land. However, we can definitely graze some cattle on it, or goats or other animals as well. So this figure here, this is interesting. They say it should be possible to provide a varied diet for the world's population if we first reserve the best land for the production of crops for human consumption, and then confine animals to grazing on marginal land or limit their consumption to crop waste. And I think that's well said. That's we're looking at food sustainability right there. How we need to use land. Of course, again, this is printed in 2011, and in the 7 years since the book has been printed, overpopulation has not decreased at all. So I think there probably needs to be other solutions in addition to that, but this is a step in the right direction. Talking about grazing, like any kind of agriculture, it has to be managed properly. And you might say, well, hey, animal production, why are we talking about that in this plant class? Well, basically, in terms of animal production, a lot of farmers especially in our area here, they don't necessarily look at themselves as cattle farmers or cattle ranchers. They look at themselves more as grass farmers. Technically, that's what they are. They are producing very diverse pastures, which technically are, a much more biodiverse agroecosystem than a cropped field. So it's interesting to examine. I think on areas where you can't produce crops, grazing is the way to go. It's relatively sustainable. Depends on the animal, of course. Swine, pigs are actually by far the most efficient converter of feed to flesh. Just to talk for a second about other forms. Of course, we talk a lot about food coming from plant products, but of course, historically, we look at also fiber and fuel coming from a lot of agriculture as well. Of course, today, and I add this in here, developed nations, most of these non-food materials have been replaced more or less by synthetic materials. And often those are a result from some fossil fuels. In some cases, it's kind of a byproduct from the fossil fuel industry. So I think that's a good thing. We figured out how to make plastics, for instance, from something that is left over from fuel production. So why not? Today, we're only looking at about 2.5% of cropland being to fiber crops. Of course, we are still growing cotton, of course. And I'm sure you guys have seen this, that hemp from the cannabis plant has a high growth potential, and they're looking at it for its demand for fiber and for clothing, and of course many other uses as well. Now also medical uses too. So interesting thing with hemp, it's an excellent fiber, many different products that can be created from it, and they're also looking at hemp seed as being a really good food source as well, and potentially a good oil source. So that's kind of one of these few sort of fiber crops that is actually on the rise, whereas cotton, of course, is still on the decline. Also think about biofuels, and biofuels basically are taking plant energy and turning it basically into a combustible energy form, usually in the form of biodiesel or ethanol. However, one of the big things I wanted to point out here with biofuels, and of course, again, the technology is changing. One day it might not be this case, but there's a lot of energy required to produce the fuels. So the net gain in fuel energy may be as low as 50%. So does it really make sense to grow corn, develop into ethanol to put in an engine? Right now, it doesn't, if that's the only thing that you're using corn for. But if you look at the large ethanol producing parts of the country, they're almost always associated with a feedlot. So basically what they're doing is you've got the corn growing right next door. They're taking the edible parts of the plant that the animals can eat, feeding it to the animals. They're taking the rest of the plant and turning it into ethanol fuel. So it's still kind of a lower percentage of the energy that you obtain through the process, but you're getting more than one use out of it. So in that way, it kind of makes sense. They're talking about here on this slide using oils for like soaps and detergents. Coconut oil and oil palm are the kind of the big ones in tropical areas. Canola and soybean in more temperate areas. So there are still a lot of plant products going into things like detergents and plastics, pharmaceuticals, etc. So still plants are being used for that. And they're looking at using biotechnology, genetic engineering, to potentially increase particular products that are difficult or have a lot of energy embedded in them to obtain. So they're looking at that as a way to potentially get more of them while using less energy. So you'll see that being developed on a larger scale in the future. Also talking about just raw materials. In 1930, plants supplied about 30%, and today over 80% of the chemicals are from petroleum products. But many scientists, plant scientists especially, believe that this trend is going to reverse, and that a lot of this chemical feedstock, raw materials for a lot of stuff, could go back to plant sources by 2050. So I think we're going to see a lot of this kind of change. The field of ethnobotany, they're talking about the study of plant usage by indigenous cultures and the preservation of that knowledge. It's important because whether they knew the scientific aspects about it a lot or not, there's still a lot of plant medicine out there. And again, I think this is another one of these trends that are going to change. Really, until the last century, most medicines were derived directly from plants. And today, only about 25% of them are plant products. But again, I think we're seeing that rising. Of course, we could look at that from, say, the standpoint of like opium poppy, for instance. They used to take that to directly derive opiate products. And then they figure out how to synthesize morphine, and then they started making them all synthetically. However, there are still some that are being produced from the plant source. The modern day medicine, and they talk about using, Native Americans using aspirin found from salicylic acid in the bark of willow trees, also some other trees too, just as an example. But there are so many different plant medicines out there that are still in use today. Of course, we can't forget about pleasure, ornamental, and recreational uses as well. Tobacco and alcohol, other recreational drugs too. Also thinking about just what E.O. Wilson coined the term biophilia. It tends to actually positively influence our psychology and physiology, just being around plants and animals. And of course, one of the most persistent kind of versions of biophilia are, the desire for plants in your house or cut flowers. And they talk a little bit about that and about how biophilia, there's a lot of embedded energy in it, especially in the US. And if we look at lawns, for instance, kind of an extension of biophilia, lawns are actually the largest irrigated crop in the United States. Kind of fascinating to think about. There are also kind of some major ecological effects from our biophilia. We've moved plants around the world, and because of that, we've developed some serious weed problems. They're talking about the horticulture kind of part of the agriculture industry here, and how a lot of our ornamentals may require even more intensive use of fertilizers and pesticides than traditional agriculture. And because of that, we're seeing a lot of kind of regulations in the more horticulture industry, trying to practice water and fertilizer recycling to lower the environmental impact. And I think one of the big things in agriculture and horticulture is how do we continue to produce just as much with less environmental impact? It's kind of a big thing that we're looking at. All right, well, that's the end of that slideshow. I know that was a whole lot in a kind of relatively brief period of time, but you've got that PowerPoint to refer back to. I'm going to put Chapter 2 quiz up today, and on Wednesday we'll talk a little bit more about our crop project. So you guys be looking through those kind of the end chapters in the book and be thinking about what crop you want to concentrate on for your project. We'll start signing up for those on Wednesday. You guys have any questions, comments, or concerns about any of that, feel free to shoot me an email. All right, well, y'all have a good day. We'll catch you on Wednesday.
Okay.